This is Steve Pilloff at George Mason University. It's talking about the future value of an annuity due. So the future value of an annuity due captures if I were to save in the form of an annuity due and I were to make T payments such that I make my first contribution to savings today, my second one in a period, my third, my fourth, and my Tth in time T minus 1, how much would I have at time T? And we'll go over the formula in a second, but let's just see graphically is I go today, make my first contribution, and then I'll compound to C times 1 plus R to the T. 1 period later, I'll make that second contribution, and it'll compound to C times 1 plus R to the T minus 1, because it's got one fewer periods to compound. This guy, C times 1 plus R to the T minus 2. This guy, C times 1 plus R to the T minus 3. And then the very last contribution, we'd show up at the bank and we'd give it, and we'd say, you know what? It's time T minus 1. I want to collect at time T. So it'll compound for one period, and then I'll show up and I would get the sum of all these future values. And that's what this expression is that the future value at time T of all of these contributions is simply the future value of all of them. And they're all the same, so we can denote them as C, and the first one today compounds for T periods, the second one T minus 1, all the way to the last one, which compounds for 1 period. Now, this is really important to understand what's going on. Through algebra, it simplifies to these expressions, but I find it a lot easier to let the calculator do this work for us, but it's important to let it know when the cash flows start, how many there are, what the rate is, and what the amount of that cash flow is. So, if we tell the calculator PMT and begin mode and end, the calculator says, aha, there are n payments equal to this amount, n cash flows equal to this amount. We're in begin mode, so the first one starts right away, second, third, fourth, nth. I% is the rate at which they compound. In addition, if we set PV equal to something, it's equal to most commonly an initial amount, but it could also be an extra special contribution to savings. But often PV is equal to negative, the opposite of the amount that's already in our account. And we go ahead and we solve for FE, and so these are generally negative numbers, putting the money into the account, solve for FE, and it'll kick out a positive number, which is how much you would have in your account. So let's take a look at an example. Lucky Lottery, 4 equal installments of 7,000. First payment later today, so there's 4 with the first one later today, 1, 2, 3, 4. Annual return is 12.2. If the money was put into a trust, how much would we have in 4 years? So look, 4 equal payments starting today. How much do we have in 4 years? So that's the future value of an annuity due. We'll do it with the calculator in a second, but what it really is 7,000 times 1.122 to the fourth. Then you get this second payment, and it would compound in 4 years to 7,000 times 1.122 to the third, plus 7,000 times 1.122 squared, plus 7,000 times 1.122. We'd make that last $7,000 payment, say we'll see in a year, and that's when we would collect our funds. So $7,000 that compounds for 4 years, for 3 years, for 2 years, and for 1 year. 7,000 for 4 years becomes a little more than 11,000. 7,000 invested for 3 years, almost 9,900. 7,000 for 2 years. We give them our last 7,000. We show up a year later after it's compounded by 1.122 for 1 to get 7,854. And we would have a total of $37,647 in the bank or in our trust. We can let a calculator do the work. Is we're going to put in 7,000. We're going to do it 4 times. We're going to start right away. It's going to compound 12.2. So if we put in 7 today, 7 and 1, 7 and 2, 7 and 3, we would wind up with $37,647.